When asked if a number is a solution to an inequality, plug the number in for the variable and see if the inequality statement is true. For example, is 6 a solution to 1/2 x minus 2 is less than -1? We're going to plug 6 in for my variable and see if we get a true statement. 1/2 times 6 minus 2, is that less than -1? 1/2 times 6 is 3. So is 3 minus 2 less than -1? 3 minus 2 is 1. Is 1 less than -1? Nope. 1 is not less than -1. That tells me that no, 6 is not a solution to this inequality. Next question. Is 6 a solution to the second inequality? We're going to go ahead and plug 6 in for x and see if we get a true statement. -1 less than or equal to 2 times 6 plus 3. Is -1 less than or equal to 12 plus 3? Is -1 less than or equal to 15? Is it? Yep. -1 is less than or equal to 15. That tells me that 6 is one of the solutions to this inequality. Remembering that there are, in fact, an infinite number of solutions to the inequality statement. Now, when solving inequalities, you're figuring out all of the numbers that make the inequality statement true, representing all of the solutions. And you're going to do this using inverse operations to isolate the variable, just like you did when solving an equation. Here is our first example. 1/2 x minus 2 is less than -1. My first inverse operation will be to add 2 to both sides of my inequality. That leaves me with 1/2 x minus 2 plus 2, which is just 1/2 x is less than -1 plus 2, which is 1. Now I want to divide both sides of my equation by 1/2. Now I want to remember what dividing by a fraction is the same as. It's the same as keeping my first number, changing my division to multiplication, and then flipping. So dividing by 1/2 is the same as multiplying by 2. And 1/2 times 2 also equals 1. So 1/2 x times 2 is just x, and x is less than 1 times 2, which is 2. This statement represents all of the solutions, all of the numbers that are going to make this inequality statement true. And I can go ahead and graph that here. X is less than 2. This is the same inequality statement that we checked above to see if 6 was a solution. And now we can see that in fact 6 can't be a solution because it's not less than 2. Only the values of x less than 2 are going to make this inequality statement true. Next example, -1 is less than or equal to 2x plus 3. First inverse operation is to subtract 3 from both sides of my inequality. -1 minus 3 is -4. And then I'm left with 2x plus 3 minus 3, which is just 2x. I now want to divide both sides of my inequality by 2 to undo this multiplication by 2, and I get -2 is less than or equal to x. Before I graph, I need you to rewrite this as x is less than or equal to -2. This is my solution to the inequality, meaning it represents all of the values of x that make this statement true. X is greater than or equal to -2. Close dot at -2 and arrow to the right. Again, I want you to rewrite this with the variable on the left so that you graph it correctly. Again, I can confirm my answer from above that 6 is a solution to this inequality, same inequality here, because 6 is in fact greater than or equal to -2. And all values of x greater than or equal to -2 are solutions to this inequality statement.